very good afternoon to everyone. I'm really excited to be here and present my work, Dusky Shark, the story of a TDS downgrade attack. I clearly remember it was a cloudy morning, and I was working on a project. And I was very close discovering a very critical issue. But there was a small problem, a challenge, that stood in front of me. And that was to decrypt a TLS traffic or make TLS between a SQL client and a SQL server. And guess what? I had success, and I'm here to talk all about it. Hello, everyone. I'm Vishal. I work at Microsoft in Azure Cloud Security team. I'm part of Azure Security team where I work on a very interesting and a cutting-edge stream in AppSec called variant hunting. We work on extracting and finding patterns from various vulnerabilities and use them to identify the root of the problems. And what I like to call that is shift to the center of the problem and mitigate those vulnerabilities. If you're hearing variant vulnerability assessment for the first time, I would encourage you to go and read more about the variant hunting at Cloud Tempo in Azure Microsoft Security blocks. With that, I move to the agenda for today. So I'll start off with a brief introduction about what is TDS I'm talking about, right? What is this protocol? And then I'll talk briefly about where it's being used and what have been the known earlier attacks in terms of downgrading this protocol. Then I'll move on to discuss the mitigation that stood fairly good in order to prevent all the earlier attack attempts. And we'll also discuss how, as an industry, we have grown and make sure that those attacks doesn't work. In the final section, I'll go over and share the details of the vulnerability or the exploit that I discovered that allows to bypass all the existing mitigation features and break the TLS for TDS protocol. In simple terms, the connection between a SQL client and a server can no longer guarantee a safe or an integrity over the wire. I'll go over the details and a short demo of the vulnerability. So without further ado, let's get started. So TDS, right? So many of you might be hearing the word for the first time, but I have strong belief that all you might have used it already. So TDS is an application layer protocol, and the full form of TDS is Tabular Data Stream Protocol. It's used between a SQL client and a SQL server. So every time, many of you have tried SQL injections, right? As a pen tester, as a security professionals, or you have tried running a SQL query. And that means you have already used the protocol behind that make that exchange possible between the client and the server. This protocol is, like I said, it's an application layer protocol. And it's very commonly used across all the known database servers. And we have a lot of drivers that support this protocol from various client devices. So with that, I'll go a bit more into the details of this protocol, how it works. So this particular protocol, right? So like I said, it's between a SQL client and a SQL server. So what you're right now seeing in the screen is there is a client, and it's trying to make a connection to the SQL server. And like I said, the protocol being used is a TDS protocol. The way it starts is very interesting. Like any other protocol, it starts on a plain text note. So everything that flows between these two, anyone can look at it. Fairly common, right? That's how most of the protocol works. The very interesting bit here is, during this transaction, both the parties share the way they want to communicate and the way they want to encrypt the traffic further. In order to establish some parallels between this and other protocols. This protocol has its own mechanism of doing SSL handshake. So with that, the very first packet is the pre-login handshake, where the client sets a pre-login handshake to the server, and the server responds back to the client. Within these two client and server packets, there is an embedded information about how they're going to encrypt the further communication. Now, there are 4 bits which exist in a pre-login handshake packet related to encryption. Both the parties can say, hey, I support encryption and I require encryption. Or they can say, I do not support encryption, and there can be a furthermore combinations of these states. So in terms of states, we have 4 different states, which is encryption is either on both sides and required, or it is off and it is not supported, or it can be in either of the combination of these classes. Once this initial handshake happens, the protocol works by making sure that they exchange the right bits and keys between each other so that they can perform a TLS handshake, and they can make sure that the communication after TDS SSL handshake is secure and it's not visible to anyone who is trying to snoop the traffic, right? And there is the last bit of this protocol comes in, where in the last sequence, now we did the pre-login handshake, TDS pre-login handshake, and then we have the initial exchange. They have decided how they're going to encrypt the entire traffic, and now whatever you see is encrypted communication. And only right after this, usually the clients will continue share the login details of SQL Server, and post that the server will verify all those details. And after verifying the details, it will, if client is trying to run a query, it will run the query on server, respond with the results, and things like that, right? Now, a very interesting thing I want to highlight here is there is a slight difference between, there is slight commonality and a big difference, I would say, if you try to compare it with other application layer protocols that we have known for very long, right? It did started at a note of a plain text, but if you look at the protocol, if we take a comparison with the HTTP or FTP and their secure versions, the protocol is fairly simple. It is just the same protocol over TLS, but that's not the case with TDS. TDS tries to handle both the plain text version and the encrypted version itself. So it's a custom logic or a custom sequence that exists there. Moving on, with that thought in mind, right, I want to go over and discuss that before I discovered the new vulnerability in this flow, what we have seen in the past. So there has been a couple of attacks over the period to downgrade TDS. And one of the very well-known attack is, or was, classic downgrade attack. Now, as the name suggests, and many of you have already guessed, hey, the client is deciding on how to do encryption, and then server is responding, and it can respond with, like, I don't support. And if there are backward compatibility support, like anyone can just downgrade it, right? And that's what the classic attack was all about. Both the side, anyone can start off, and if there aren't proper settings, they can downgrade the attack, saying like, hey, I don't support encryption, and that entity can be either side of the party. It can be a client or a server. Adversary in the middle can inject that information. Over the years, we evolved from that, and the SQL Server started coming up with a default flag saying, we will not allow an unencrypted channel. So now it becomes harder, right? Because even if you do an adversary in the middle attack, the server will not gonna proceed with the connections, right? And that's what gave rise or discovery of asymmetric downgrade attacks, which is basically you have a server which has all the right configuration to not downgrade. But at the same point, you have a client which can accept both, right? It can accept, it can work over a plain text communication. It can work over encrypted communication. And basically, at a fundamental level, what the asymmetric downgrade attack is, an attacker or adversary injects itself in the middle. It talks to the client in a plain text language, and then it converts the same communication to an encrypted one to talk to the server. It's like a transparent proxy it creates in between. And that's what is an asymmetric attack is all about. Another interesting attack in the same realm we have seen in the past is the certificate forgery. So like I said, it's a TLS. Like there is a handshake happening, and both the entities need to establish their identities, right? So there are settings, or I would say configuration, which can make it possible to like provide a self-signed certificate, and that can basically, if our clients are not hardened to do the proper assessment, it can again lead to the same flaw where an adversary in the middle can decrypt the entire traffic and cause an havoc, right? So with this, like these are the few attacks that we have already seen, right? With this in our mind and looking at how the protocol works and the attacks we have seen evolving over the years, and I discussed about asymmetric attacks. And again, like over the period of time, we have built and established methods to prevent these attacks. And many might have you already be using it on the client side. Like I said, if client is not secure, client can be vulnerable to an asymmetric attack where, hey, we have a good hardened server, but the client is not hardened enough to leak its credential, right? And I want to discuss few of the driver mitigations or the client-side mitigations that exist that have protected us from these asymmetric attacks. Of course, before I discovered the new vulnerability. So these two flags are very important. So the one of the flag on the client driver is encrypt true. And what it does is it makes sure that if somebody or the server does not support an encrypted communication, it will gonna make sure that it will throw an exception and it would not let the client credential pass over the network, or it will not pursue that connection at all. The other very important flag is the trust server certificate. Like I discussed about the certificate forgery, right? This flag makes sure that client identifies the integrity of the identity of server by the chain of authority. And this is what the mixture of these two flags prevent us from asymmetric attack. And they were very good at it. They have prevented these attacks for many, many years. This is a sample connection string on the client side, which a client driver or a SQL communication driver uses to connect to the server. You might have seen this in work or in source code or in the configuration files. And again, I want to highlight these two security features, which make sure that client is secure and there is no feasibility of doing adversary in the middle attack. OK, so just a quick recap. We discussed what is TDS, where we have seen the protocol in work. And then we went over some of the known attacks that existed in the past to downgrade TDS. And then we kind of looked into what were the mitigations that we were consuming to prevent those attacks, to make sure that all the communication between a SQL server and a client is secure. Now we'll go over and see this vulnerability, which bypasses both the mitigation that existed very well till now. So before I move on, I just wanted to quickly show the TCP packet or the pre-login packet, because this is a very important and interest of ours. So if you look at this packet, it's a client pre-login packet. The structure remains the same between the pre-login message that client sends to a server and server sends to the client. It's just its type changes. So if you look at the information in this packet, like pre-login message, and there are a lot of options if you look at the bottom. And one of the very interesting options that we are interested into is encryption. So I want to zoom into this, right? So we saw, OK, so this is how protocol starts off. And we have a feature on the client driver side of SQL Data Client that will make sure that if server is not supporting the encryption, it will not going to establish a connection, right? And the bit that comes into the picture, or the thing that client driver reads, is this options message, which is the encryption bit. Now I want to quickly double-click on the vulnerability and show you a snapshot of how it looked when I first looked at the code. So the red highlighted one is something which existed. And the first time I looked at it, I was very surprised. So if you look at this, this is a simple code, right? There are some switch statements, then there is a default case. The thing that intrigued me a lot was, if you look at the switch statement, it is based on an encryption option. And we looked at it, right? We know that there can be 4 different values of that option. But the thing that interested me is, what if this option itself does not exist? Because all this switch case is doing is making sure that when there is an option, it will gonna do the right thing. So if there is an option and it says server does not support encryption, I'm gonna make sure that I throw the right exception and drop the connection, right? And again, given the condition that client is using all the mitigations we discussed, right? The encrypt true flag and then the server certificate flags. And if you closely look at the default cases, so default wasn't existing. So like I said, this is a snapshot of a PR. And there wasn't any default. And I thought, no, this can't be real, right? I thought that means if I provide a packet, a pre-login packet, without a bit that signifies an encryption option, I should be in, right? And that worked. So this is a genuine packet. And if you look at the payload, it's just you flip the bit, change it to any other option. I change this to inst option, but you change it to any other option, and that logic will never get hit, and the connection will succeed. So all the mitigation that stood, the encrypt true and trust server certificate will fail, and an adversary in the middle will be able to successfully do an asymmetric downgraded attack. Now we're going to have a look at a quick demo. This demo shows you that how this attack really works. And it will show you that how a victim, completely unaware of what is happening in the background, is doing his usual work, opening a client and trying to access some data from the server, unaware that something is happening in the background. So let's have a look. So here, you can see that victim comes in and he logs into using his SSMS or any desktop client which can connect to the SQL server. Everything looks fine, right? He's able to connect. Now let's have a look at the adversary side, who is acting as adversary in the middle. So what we see there is he's receiving all the details because he was able to successfully perform a asymmetric downgrade attack. So like I said, all the bits, all the credentials that were supposed to be encrypted now flows through the adversary, and he can have a look at everything. Victim, completely unaware of this, continues doing his work, fetching some data from running a SQL query. Everything is passing through the victim, and the downgrade was successful. Now let's just double-click what happened. Like I said in this demo, a TDS client started a communication. The adversary in the middle, very intelligently, like we discussed, responded with a bit flip of removing the encryption information from the server pre-login packet. And what happened is, as a result, the adversary was able to act as a bridge between the client and the server, creating an open channel, unencrypted channel between the client and the adversary, and at the same time, opening a channel between itself and the server in an encrypted format. So let's recap what we discussed, right? So this is an analysis of the exploit we just saw. So what are the preconditions? The precondition to perform this attack is the communication between the SQL client and the server must be requiring a driver, which is SQL Client driver, or Microsoft Data SQL Client. And the adversary should be able to perform, the adversary in the middle should be able to inject between the client and the server. As a result of this, what will happen is the channel between the client and the server can't be guaranteed encryption. Like, we can't guarantee an encryption in the motion. And like I said, it bypasses all the security features we built in those drivers. Here is a timeline of this vulnerability I discovered and the things we discussed, how it got introduced. We saw the different type of attacks, downgrade attacks, like classic, asymmetric, and then the one I just showed you of, the CVE 2024-0056, which bypassed all the existing measures to downgrade a TDS TLS connection to a plaintext. These issues have been already fixed in all the versions of SQL Data Client and Microsoft SQL Data Client libraries. So I just wanted to go and discuss about the mitigations. And I want to highlight a bit here. So we discussed the protocol, and we saw some nuances of there is a problem when we are observing the sequential flow, the sequence diagram of the protocol itself, right? And for that, so you have two options now. Like we discussed, there is a slight deviation in the way TDS works. In the upcoming versions of TDS 8, it is going to be as simple and as equivalent to HTTP on TLS, which we know as HTTPS. So it will be TDS on TLS. And one of the mitigations to prevent is to use TDS 8. You can opt for this by setting up the encrypt flag as restrict, and that automatically makes sure that your default protocol between the client driver and server is TDS 8. For the vulnerabilities that I just showcased, it was released in patch Tuesday of early January this year. Most of the Windows system, if auto upgrades are enabled, they are already covered for the fixes, and you might have already upgraded. There are details of the versions which were vulnerable that you can see, and if you have any dependency, you know what this vulnerability can do, and you can take an action. So here are some resources and links that I discussed. With that, thanks a lot. Thank you so much.